So let us discuss first here why concentration is important. Why should we study about concentration, or what is concentration? Concentration is the amount of solute added to the solvent. It is the amount of solute present in the solvent. So first thing is this, it is the amount of solute present in solvent. What determines the concentration? Amount of solute present in solvent, right? More solute present in solvent, more will be the concentration of solvent. Now there are actually two types of solutions: dilute solution and concentrated solutions. What are dilute solutions? In which the solvent is of higher quantity and solute is of lower quantity. Say 1 gram of solute in 99 gram of water, right? But if we talk about concentrated solution, here solute is present in maximum amount, or say in larger quantity, and solvent is present in less quantity. So more the solute is present, more will be the concentration of solution, right? Say 50, say one side we are having 50 grams of salt in water, and other side we are having 10 gram of salt in water, right? So which solution will be more concentrated? This one, which is having more solute present in solution, right? So why there is a need to study about the concentration? Why do we study about the concentration? So let's take an example, a common example here. You see, in a hospital, if a doctor is performing a surgery, and for that they are giving an anesthesia to a patient, okay, so that patient won't feel pain, okay, or the patient will get faint, right, while operating. So what if now we know about the concentration, that more solute, if we add more solute, more concentrated a solution would be, okay. So if uh, the patient is not fainting and we are giving, so we think, let's try to give a patient more anesthesia, more concentrated anesthesia, right? So this may result in the death of a patient also, right? So concentration is actually very important to get the precise quantity of solute present in it, right? So why do we measure the concentration of solution? To get the precise quantity of solute, right? So there are basically 7 methods, or say 7 different ways to determine or to find the concentration of solution. To check or to determine the concentration of solution, that is the solution. What is the concentration of solution is? So what are these 7 different ways? Here is about the concentration of solution. As I have told you, there are 2 types of solution, that is dilute solution and concentrated solution. Here in dilute solution, less amount of solute is present in more amount of solvent, and in concentrated solution, more amount of solute is present in less amount of solvent, right? So the components in the solution, they can be expressed in terms of their concentration, right? So it can be expressed as qualitatively, but more quantitatively. Okay. So what are the ways to calculate the concentration? As I have said, there are 7 different methods to express the concentration. First is mass percentage, right? This is also known as mass by mass percentage. Let us quickly see here what other methods are. First is mass percentage method, second is volume percentage method, third we will study about mass by volume percentage, and then mole fraction. Fifth would be ppm, that is parts per million. Okay, to get the accurate, precise amount of solute present in the solution. Sixth will be molarity, and seventh method we use to check the concentration of solution is molality, right? So out of these 7 methods, first method we are discussing here is mass percentage. So what is mass percentage? It is defined as the mass of a substance divided by total mass of solution, right? For example, say I have 10 gram of ethanol or say glucose. C6H12O6, this is the formula of glucose, okay, in 100 gram of solution, right? So what will be the concentration of solution by mass percentage? This means that we are having the 90 gram of water present in the solution and the 10 gram is glucose, right? So by this we can calculate the percentage amount of solute present in the solution, right? As you can read an example here, what do you understand by 100 gram of solution having 10% of glucose in water? This means that solution is having 10 gram of glucose. So this is easy to calculate, right? Other method is volume by volume percentage. It is defined as the ratio of volume of substance to total volume of solution. Volume percentage method is used to check the concentration of liquid solutions, right? What is the formula we use? The earlier one we used to calculate the concentration of solid solutions, right? This one, weight by weight, this is for to calculate solid solution concentration, and this method for liquid solutions. Okay, so the formula we are using here is volume of a substance by total volume of a solution multiply by 100 to get the percentage. For example, if I write here 10% of ethanol, what does this mean? 10% of ethanol, this means 10 ml of ethanol, the C2H5OH, okay, in 90 ml of water, okay. Third is mass by volume percentage. We will do the worked example and questions, we can use, we will use later this formulas to calculate concentration of solutions in numericals, right? The last one is, the third is mass by volume, where we are taking a solute. Okay, we are calculating the mass of solute and then we are adding it into a solvent. Okay, we are measuring the mass of solute and we are measuring volume of solvent and we are mixing them to form a solution. So how much is the concentration of solute present in it and how much solvent we have taken to form a solution, right? To calculate that, we use this third method to calculate the solid concentration in a solution, or say liquid concentration in the solution. We use this mass by volume percentage, right? So this method is usually used in pharmaceutical industries to prepare medicines. Okay. Right? Here you can see the example for mass by volume percentage. What do you understand by a solution having 2.5 gram of potassium chloride in 50 ml of KCl solution? Now what this means? We are having a KCl solution, that is potassium chloride solution, where potassium is present 2.5 gram, that is a solute, and what is the volume of solvent? That is 50 ml, right? So that means the total volume of solution is 50 ml, where the solute present is 2.5 gram. So by using this formula, that is 2.5, which is the mass of substance, and what is the volume of solution? It is 50 multiplied by 100. We can calculate the mass by volume percentage, right? I hope this is clear to you, that how we are going to use these formulas in numericals. Okay, so this is the easy and basic formulas to calculate the concentration of solutions. The fourth one is parts per million. It is also known as ppm. In the exam, full form of ppm is very usually asked in CBSE exam. This is a very basic question, that what is the full form of ppm? It's parts per million. What is ppm? It may be defined as the number of parts of substance divided by total number of parts of all substance. Parts per million means 10, 10 by 6 is represented here, the millionth part. Okay, so why we use this? It gives the precise, or say accurate amount, accurate or say precise amount of solute present in solution. This method of calculating the concentration of solution gives the precise amount of solute present in solution. This is very much used in pharmaceutical industries. Because why this is used? Because there is one chemical naming carbon monoxide. Okay, it's the minimal amount of carbon monoxide present in solution can cause death of a person, right? So that is why it is considered as the accurate method to make medicine, right? Other example is chloroform. Okay, to give chloroform to someone to faint them, we use very minimal amount, right? Yes, if we give them a large amount, it can cause the person to be fainted for several days, right? So to get the minimal amount of such reactive substances, we use ppm method, okay, to get the precise or accurate amount of solute to be added in the solvent. For example, if we read here, find the concentration of oxygen in parts per million in a sample that contains 5.8 into 10 raised to power minus 3 gram of dissolved oxygen per kilogram of sample. Now here we have given a sample, okay, that contains this much amount of dissolved oxygen. But we have to find what is actual concentration of oxygen present in this sample. For that, we can use this formula, that is number of parts of substance. How much it is given? 5.8 into 10 raised to power minus 3 by the total number of substance. What is the total concentration? 10 raised to power minus 3, that is 1000 grams. And we have to multiply it by 10 raised to power 6, that is parts per million, to get the accurate amount of, or say accurate concentration of oxygen present in solution. So I hope this method is clear. So let's move on to our next method, fifth, that is mole fraction. This is very important to and is very highly used in calculating the concentration of solutions, right? So what is mole fraction? It is generally represented by X. Okay, if you can read the definition here, mole fraction, it is the number of moles of a substance by total number of moles of all substances. Let's see an example here. If you can see an example here. What do you understand by moles of fraction of methane in gaseous mixture being 0.90? That means that 90 mole fraction of methane indicates that 90% of the gaseous solution contains methane, that 90% of methane is present in the solution. Okay. For mole fraction, the formula is generally XA is equals to NA over NA plus NB. Right? That is nothing but these number of moles of substance by total number of moles of all substances. Right? If say more than two number of substance given there in a solution, we can also use this formula as I. Okay, and it can be represented as Ni, that number of moles of any number of substance divided by summation Ni. Alright, summation means sum of all the number of moles of substances. Right? Here, one thing is important to note. That in a solution, sum of all mole fraction is unity. Sum of all mole fractions is unity. This is very important point, and this will be used in the upcoming numericals. Okay. In a solution, sum of all mole fraction is unity. That is 1. Alright. That means sum of all mole fraction is denoted by x, say x1 plus x2 plus x3, so on, xi, that will be equals to unity. Alright, this is an important point to note. Number 6 method is molarity. It is represented by capital M. Another method to calculate or to express concentration of solution. What is molarity? It is defined as ratio of moles of substance to the total volume of solution. At moles of the given solute, what is a mole? It is the smaller quantity of a solute. We express, this is a unit of solute, okay, divided by the total volume of solution in liter, right? For example, if I say 0.25 mole liter inverse, mole will be the unit of solute and liter will be the unit of a solution. That means mole per liter is the unit of molarity. Okay, so if I say 0.25 mole liter inverse, mole per liter of NaOH, is present in the solution, right? So what that means, this is, we can also write it as M, capital M, right? This means that 0.5 molar of solution of NaOH is added to 1 liter of solution, right? This is how we read the statements if it is given in a numerical. 0.5 molar of solution of NaOH. This means that 0.5 moles of NaOH is present in 1000 or say 1000 ml of solution or say 1 liter of solution, right? So this is the last method to calculate the to express the concentration of solution, that is molality. It is expressed in as small m. Okay. Here definition of molality is moles of solute by mass of solvent in kilogram, right? You can understand this by an example given here. What did you, if I ask you what did you understand by 1 mole of solution? That means that 1 mole of potassium chloride is present in 1 kilogram of solution, right? Let us do some worked example here. Now you see, we have studied all the 7 methods to calculate the concentration. Here is the first method that we have studied, that is the mass percentage. Now let's try to solve this example. Here the question is given as 12 gram of urea. Urea is what? Solid, that is solute. It is present in 1000 gram of water, right? What is this 1000 gram? This is the volume, okay, and this is the mass. Sorry, this is weight by weight. This is present in grams. So this is the mass and this is also the mass of solute. Okay, so you have to find the percentage of mass by mass of the solute in the solution. So I think you can easily do this. As you can see here, we are given the mass of urea, that is 12 gram. Mass of the solvent is given, that is 1000 gram. Okay, to calculate the mass percentage, what is the formula? Yes, what is the formula to calculate the mass percentage. It is the mass of solute by total mass. It is the mass of solute by total mass of solution into 100. What is the mass of solute? That is 12 gram. What is the total mass? Total mass would be of solute plus solvent, right? They together are forming a solution, right? So what is the solute here? That is urea, that is 12 gram. Okay. That is 12 gram. And what is solvent here? That is water, that is 1000 gram. So if we add them, it becomes 1012 gram. That is the total mass. Okay. And by multiplying them by 100, we can get the mass percentage, that is weight by weight, or say mass by mass of a solution. So I hope you can do the example for mass percentage very easily, right? Next, let's do an example for volume by volume, where the solution is made from both solute will be liquid, okay, and solvent. This will also be liquid, right? That is why it is termed as volume by volume. This volume percentage we use to calculate or express the concentration of solution, where the solute and solvent, they both are liquid. Now again, as we have done with the as we have done here to calculate the mass percentage, in the similar way we will do to calculate the volume percentage, right? So here, as you can see, read the question. Find the volume percentage of a solution having 30 ml of alcohol. Alcohol is what? Liquid. In 120 ml of water. Water is again liquid. What is the formula for volume percentage? Yes. Volume percentage is what? Volume of solute by total volume of solution, right? And multiply by 100. Volume of solute is 30 and that of water is 120. Solute is 30, water is 120. For total volume we have to add them, that will be 150 ml, right? 30 by 150 multiply by 100, so 20% will come out as volume percentage, right? Let's do an example for the third method that we have done, that is mass by volume percentage. Mass by volume percentage, where we use to make medicine, mainly used in pharmaceutical industry, where solute we take a solid and solvent we take as liquid, right? So I am moving this question here only. I want you to try this on your own, right? So can you read the question? Find the mass by volume percentage of a 100 ml solution having 3.5 gram of NaCl. Apply the formula and do this question, right? What is the formula for mass by volume percentage? It is, yes, mass of solute by total volume of solution into 100. Very easy. Okay, mass of solute. That is why I have put stress on explaining you the formulas. Okay, the numericals are very easily, can be solved very easily if you know the formula, right? Let's do one numerical for parts per million. Question here is 348 gram of solution contain 0.551 milligram of acetylene. Okay, you have to find the concentration in parts per million. Same formula, mass of solute is given here. That is how much? Where is the mass of solute? It is here. Okay, what is solute? This is STT, right? And mass of solution, that is 348 gram multiplied by 10 raised to power 6, that is parts per million. You will get the value for parts per million, right? Let's move on to our next numerical, that is based on the fifth method that we have studied about expressing concentration or calculating concentration, that is mole fraction. Can you tell me the formula for mole fraction? Number of moles of solute over total number of moles, right? We have also written this as this, right? So if you can read the question here, find the mole fraction of ethylene glycol in a solution that contains 20% of ethylene glycol by mass. Mole fraction of ethylene glycol in a solution that contains 20% of ethylene glycol by mass, right? So you can solve this easily. All right, so try to solve this numerical on your own. Right. For molarity, as you know, what was the definition for molarity? It is the moles of solute per volume of solution, right? So let's see an example here. What would be the molarity of a solution that has 10 gram of NaOH in 900 ml of solution? What would be the molarity? First, we have to calculate the molar mass of NaOH. Okay. Sodium, atomic mass of sodium is 23, oxygen is 16, hydrogen is 1, total mass, total weight of NaOH is 40 gram, right? Now first we have to calculate moles of NaOH, given mass that is 10 gram and molar mass that is 40 gram. We can calculate moles of solution. Why we have calculated this mole of solution? Because when we are going to apply the formula for molarity, that is mass of solute by volume of solution, there required the moles of solute. That is why, right? So I think you can easily do the questions regarding the molarity, mass fraction, mass percentage, volume percentage, mass by volume percentage, parts per million, right? And here is one example for molarity also, similar to molarity. What we are going to do, let's look at the question only here. Find the molarity of 5 gram of acetic acid in 150 gram of benzene. Yes, acetic acid. Let me give you the formula for acetic acid here so that you can calculate the molecular mass. Acetic acid is BH3COOH. Calculate the molecular mass first. Atomic mass for carbon is 12. Hydrogen is 1. How many hydrogens are there? 3. And carbon, and then oxygen, that is 16. Again oxygen 16. Hydrogen 1. Calculate the molecular mass. Okay. Then calculate the moles present. How are you going to calculate the moles? Here the given mass by molecular mass. Okay. Then what you are going to do, apply the formula for molality. That will be the number of moles that you will get here. Okay. Divided by total volume, that is 150. All right. So I hope you can solve this question on your own. Okay. Right. So what we have done here, we have calculated the molecular mass, right? Here of acetic acid, we have calculated the moles, and then we put it the formula of molality, right? So I hope you can solve all these numericals, whatever come in the chapter. or in the exam, I think you can easily solve this. Right? I hope these all the miracles for expressing concentration in solution is clear to you now. Right? Let's look at one or two questions. This question is of assertion and reasoning here. Let us quickly solve this question. We have done the numericals for all them. Let's do the assertion reasoning question. Assertion is given as the compared to molar solution, a molar solution is more concentrated, right? And reason is why it is more concentrated, that 1 mole of solute is present in 1000 ml of solution. Is this assertion correct? If we compare to the molar solution is more concentrated. Yes. So it is correct. If we compare the molar solution is more concentrated because solute is present in 1000 ml of molar solution. So don't get confused here for 1000 ml. The formula for molarity is number of moles, okay, present in per liter of solution. That is volume of solution we are taking in liters. But if it is in milliliters, the formula will become number of moles per volume of solution in milliliters multiplied by 1000. So that is why both assertion reasoning are true, and reason is the correct explanation for A. Right? So this is how you're going to solve the assertion reasoning questions. Let's look for the other question. Here the assertion is given as the HCl solution at 0.1 normal. This is normality. And 1 molar, that is molarity, 0.1 molar. For HCl solution, we have given 0.1 normality and 0.1 molarity. The reason is a solution normality and both. So in the reason they are saying that normality and molarity, they are equal. No, they are not equal. Normality is the twice of molarity. All right. So what will be the answer? Yes, option C is correct. We can say A is assertion is true. We can consider them, but the reason is false. They are not always equal. Why? Because normality is the twice of molarity.